Hello everyone, welcome to Technologies Discussion Channel. Today, I'd like to continue the discussion on antenna design. This video, I'm going to share what will be the required condition so as when the transmitter and receiver antenna can be interchanged. In short, for example, when I actually design this antenna as a transmitting antenna, when will be the condition that is actually required so as to be the same transmitting antenna to be function as a receiver antenna. So basically, this will be the objective of this video. Okay, the key reason why transmitter and receiver antenna can be interchanged is because of this theory. Okay, so because of this antenna reciprocity theorem. So therefore, we can actually interchange the transmitter and receiver antenna. Guys, if you're keen to know more about antenna design, okay, please take a look on the playlist under the description. Over there, you will be able to find a series of discussion on antenna design. This is my email. If you have any question regards on this discussion, okay, please drop me an email. Okay, or if not, if you want to have a faster response, you are always welcome to ask me your question through the comment. Before I continue, okay, I'd like to urge you guys to help this channel by like this video. Help me guys press the like button now. If you are new to this channel, please consider to subscribe and turn on your notification bell. Once again, thank you so much for strong support. Let's just imagine this. For example, you just built an transmitting antenna that basically this transmitting antenna meet your gain, your bandwidth, and impedance requirement. So now you actually consider this antenna, okay, to use as a receiving antenna. So now you will probably ask, okay, were all these parameters that are actually designed for transmitting antenna, the gain, the bandwidth, and impedance, will they still remain the same when I actually switch into receiver mode? So basically this video, I will address all this. Okay, so the answer actually lies in a fundamental property of most antenna, okay, which is the reciprocity. Okay, so because of this antenna reciprocity, okay, so the key characteristics, for example, the impedance, the gain, the radiation pattern, the bandwidth, and resonant frequency, they will be still the same, okay, whether you actually want the antenna as a transmitting antenna or receiving antenna. Okay, so this principle was mathematically established by Lorentz through the reciprocity theory. Okay, however, because this Lorentz involved a lot of mathematics, okay, so in this video, okay, like I mentioned earlier on, I always want to avoid the tedious mathematics, so I will use another so-called theory, okay, to let you know that actually transmitting and receiving antenna can be interchanged. Okay, so basically, all this will be the objective of this video. Okay, so now let's take a look on these two diagrams. Okay, so if a voltage is applied to the terminal of an antenna A, so from here you can see that I actually apply a voltage at the antenna A, and then I actually measure, okay, the current at the antenna B. So now on another situation now, okay, so now I actually put a voltage at the antenna B. So now I actually measure the current at the antenna A. So now, okay, if the voltage is the same, then the current will be the same. So in short, when I actually apply a voltage at antenna A, when I measure the current at antenna B, it should be the same at the antenna A when I actually has the same voltage source at the antenna B. Okay, so basically this is what you want to mention over here. Okay, so basically this is actually a consequence of this theorem, is that the antenna gain must be the same, okay, whether we use it for receiving or transmitting. Okay, so basically this is the antenna reciprocity theory. So we have these two antenna, okay, two antenna reciprocity. Okay, so this input impedance are Z1. Okay, so basically this is the input impedance Z1 and also Z2 here. Okay, so they are actually separate by a linear and isotropic, okay, but not necessarily homogeneous medium. okay, as shown over here. So one antenna, okay, so the first antenna is used as a transmitter, and the antenna 2 actually used as a receiver. Okay, so the equivalent network of each antenna is actually shown below here. The internal impedance of the generator, okay, so basically this is the internal impedance of the generator is assumed to be the conjugate of the impedance of antenna 1. Okay, so basically this is actually the impedance of antenna 1. You can see that the internal impedance of the generator is actually so-called complex conjugate. As you can see from here, this is plus, this become minus. So this is what we call conjugate. Okay, so of the antenna 1, okay, as you can see from here, so basically ZG is equals to Z1. Okay, so conjugate. So therefore, this is actually the value of ZG, which is R1 minus JX1 here. Okay, while the load impedance ZL, okay, so basically this is the load ZL, is actually equals to the conjugate of the impedance of antenna 2. Okay, so this is actually the value of antenna 2. Okay, so basically the load, okay, again will be the conjugate, okay, of the antenna 2. So basically, this is the outcome equivalent network of these two transmitting and receiving antenna. Okay, so the power that is actually delivered by the generator to the antenna 1 is given by this equation. Okay, so basically this is the equation to calculate the power. Okay, so how to get V1? Okay, so basically this is the location of V1. Okay, how can I actually know the voltage V1 here? I can actually do the voltage divider rule. Okay, right? So V1 is actually equals to VG multiplied by the impedance here, which is Z1, okay, over the total impedance, which is ZG over Z1, as you can see from here. Okay, so basically this is V1. Okay, so basically they obtained by the voltage divider rule. So VG multiplied by Z1, okay, over the total, so-called the total impedance, which is Z1 plus ZG, as you can see from here. How can I actually get I1, okay, which is the current one that is actually flowing through the generator? Okay, so I have the total voltage, which is VG, okay, over the total impedance, which is Z1 plus ZG. Okay, since this is a conjugate, so I keep this two term conjugate. Okay, so how I actually arrive at this final number here? Okay, so let's take a look on this first. So Z1, okay, which is equals to R1 plus JX1 plus ZG, which is R1 minus JX1. So basically, you can see that, okay, the imaginary part cancel each other. What I left over will be 2R1. So this one, I will left 2R1. For this case, will be the same. I left over 2R1. So when I actually multiply these two together, I will have 4R1 squared, right? So you can see that I actually just need the real term of Z1, so it will be R1. So therefore, I only left one term of R1 at below here. And this is actually 4. Remember, there's actually 2 here. So 2 multiplied by 4, which is 8. So therefore, this is actually the power that is actually delivered by the generator to the antenna 1, okay, which is this amount of power, okay, that is actually sent to the antenna 1. Okay, so next, okay, so if the transfer admittance of the combined network consists of the generator impedance, antennas, and load impedance is Y21, okay, the current through the load is actually equals to BGY21, and the power delivered to the load is actually this. Okay, so basically this is another equation here. So basically you can see that this is actually the current term. Okay, so this is actually the impedance. When I actually so-called expand this, I will actually obtain this equation here. So earlier on, I have calculated my P1. So now I actually calculate my P2, okay, which is to the load. Okay, so basically P2 is how much will be delivered to the load. Okay, so this is what I have calculated earlier on. So this is actually where I actually obtain from here. Okay, and then P2, okay, basically is what I have calculated from this equation here. So if I do a ratio, okay, P2 divided by P1, which means that this guy divided by this guy. Okay, so this guy, okay, basically divided by this, and this 8R1 become on top, this BG will cancel each other. Okay, so basically this 8, okay, basically will become 4, because 8 divided by 2 become 4. And I have my R1, okay, and R2, and also my Y21. Okay, so basically this is actually the ratio. Okay, so in a similar manner, okay, we can actually show that when antenna 2 is actually transmitting and antenna 1 is receiving, okay, the power ratio of P1 over P2 will be the same. So for this case here, you can see that they are actually reciprocity, okay, which means that Y12 equals to Y21. The power delivered in either direction is the same. Okay, so basically with this, you can see that, okay, whether these two antenna, okay, whether they change their property, they will be still the same power that deliver in either direction. Okay, so basically this is what we understand on the reciprocity for two antenna. Now let's understand, okay, when the condition we can actually interchange the role of transmitting antenna and also the receiving antenna. Okay, so the transmit and receiver antenna, okay, they are actually interchangeability. Okay, they actually refer to the ability to use the same antenna for both transmitting and receiving signal, either simultaneously or alternatively. Okay, so later on you will see this. Okay, so this is possible under certain condition, primarily determined by the antenna design, operating frequency, and system requirement. Okay, so here are the key scenario when transmitter and receiver can be interchanged. Okay, so these are the 6 reasons, okay, why when the transmitter and receiver antenna can be interchanged. First reason will be the reciprocity principle. Okay, so basically antennas are generally reciprocal device, okay, which means that their radiation and reception pattern, okay, whether their gain, directive, and impedance, they are the same, okay, regardless whether they are used for transmitting or receiving antenna, which I have mentioned earlier on. Okay, so when they actually interchange, okay, if an antenna is linear and passive, okay, as long as I need to ensure that there is no active component like amplifier that is actually added to the transmitter, for example, then therefore it can be typically be used for both transmitter and receiver at the same frequency. Okay, so basically this is the first reason, okay, when transmitting and receiving antenna can be interchanged. The second reason is the frequency compatibility. Okay, so we have two scenarios when we actually have the same frequency, and also another scenario will be at the different frequency. Okay, let's study the same frequency first. For example, if the system actually operate in a half duplex, okay, which means that they transmit, okay, not at the same time. Okay, so which means that they transmit and receive at different time. Okay, so basically like in radar or walkie-talkie. Okay, so walkie-talkie, okay, so just imagine when you actually want to transmit, you press the button, you actually transmit. Other than that, you actually receive. Okay, so the same antenna can be switched between modes. Okay, so you have the same antenna, you can actually switch them as transmitter or receiver mode. So from here, you can see that they actually use the same frequency, okay, but based on the so-called switch, okay, you can actually switch them as a transmitting antenna or receiving antenna. As for another case is for the full duplex case here, which means that we actually simultaneously transmit and receive at the same frequency. Then we need to have a special design like circulator or duplexer. Okay, they are actually required to isolate the transmit and receiver signal. Okay, so basically there are some application in radar or in some communication device here. Okay, so basically this is under the same frequency, okay, that there is actually make the transmitting and receiving antenna interchangeable. From here, you can see that I actually list up the half duplex and full duplex mode that we can actually share the same antenna with the same frequency. So now, okay, I'm going to explain on the different frequency. Okay, for example, the FDD, okay, which is the frequency division multiplex. Okay, which means that okay, every task, every user they have a unique frequency to transmit. Okay, for example, the cellular base station. Okay, so therefore the antenna design must be able to support both transmit and receive band. Okay, which means that you must design an antenna to have a dual band, for example, okay, to support both the transmit and receiving band. Okay, but they may require duplexer so as to separate the frequency. Okay, so this is actually the second reason, okay, when the transmitting and receiving antenna can be interchanged. Okay, the third reason is the power handling. Okay, so most of the time, okay, the transmitting antenna, they need to handle very high power. Okay, for example, for radar, okay, you actually boost the signal, okay, quite significant high power before you actually transmit. So therefore, for transmitting antenna, they must be able to handle high power without damage. As for receiving antenna, they have different tasks. They mainly, okay, tasked to receive weak signal. Okay, so basically they will be concentrate on the receiving mode, on the receiving very weak signal, and then boost up the signal. So therefore, when we actually do this interchange, okay, so if the antenna power rating is sufficient for transmitter, it can be often used for receiver. Okay, but on the reverse so-called case, it is not possible, which means that, for example, okay, for receiver, okay, basically I will not have the power rating to protect the transmitter under the high power. Okay, so basically this is one thing that you need to take care, okay, before you can interchange the transmitter and receiver antenna. Next will be on the polarization and radiation pattern. Okay, so the antenna polarization, okay, whether is it linear, circular, okay, and the radiation pattern, they must be matched for both transmitter and receiver. Okay, keep this in mind. Okay, so when you actually transmit and receive, okay, you must remember this. The polarization must be the same for both transmitter and receiver, which means that, for example, if my transmitter is linear, so therefore my receiver must be linear also. Okay, so if they decided to switch to circular, both the transmitter and receiver must be circular so as to have a better chances to receive and or transmit the signal accurately. Okay, so basically the example will be a circular polarization antenna for satellites comm must maintain the same polarization for transmit and receiver so as to avoid signal loss. Okay, so basically this is the fourth reason, okay, when you can actually interchange the transmitter and receiver antenna, you need to ensure that they have the same polarization, okay, and also the radiation pattern. Next, on the reason number five will be the system architecture. Okay, for example, most of the time now, the state of the radar system, okay, we always have this TR module, which means that they can switch to either transmit or receiving mode, okay, using the same antenna, which I have described earlier on. Okay, so basically this is a key application for radar. So what happened here is basically you just need to have one antenna and they can be function as both transmitting or receiving antenna because of just one switch. The switch will switch them as a transmitting mode or a receiver mode. We also have this MIMO facial array. Okay, so antennas in this system, they are typically shared for transmit and receiver. Okay, but they actually require careful calibration. Okay, so basically this MIMO or facial array, okay, so basically the transmitter again, okay, the antenna can be function for both transmitter and receiver antenna. Okay, but we need to be very careful in terms of the calibration on this. Okay, so basically this is reason number five on the system architecture. Okay, my last one will be the time division multiplex TDD system here. Okay, so in this time division multiplex, okay, for example, for Wi-Fi, for 5G, okay, the same frequency is used for transmit and receive at different times. Okay, so antenna are inherent interchangeable. So basically this is quite clear as compared to the frequency. So basically they transmit at different time. Okay, so using the same frequency. So all these antenna, they can be function both as a transmitter and also a receiver. Okay, so basically these are the five reasons, okay, six reason when the transmitter and receiver antenna can be interchanged. Okay, so now let me come into another extreme condition, okay, when interchangeability is not possible. Okay, so for the active antenna, okay, earlier on I did mention this. If you have a active antenna, okay, for example, if the antenna has integrated amplifier, okay, especially for transmitting so-called antenna, okay, you actually have an amplifier to boost up the signal, or we have filter that is actually optimized for only transmitter or receiver, then we cannot interchange the transmitter and receiver antenna. Next will be asymmetric design. Okay, so some antenna, okay, especially when we actually design for high gain, okay, transmitting antenna, okay, so basically this will have asymmetric design, okay, for uplink versus the bob pin receiving antenna, okay, so basically they are purposely built for only one direction. So therefore, this type of antenna may not be suitable to interchange transmitting or receiving antenna. Last but not least, isolation requirement. Okay, so in high power system, okay, for example, under the broadcast, okay, the receiver antenna may need physical separation so as to avoid overload. Okay, so basically, because we transmit very high power, okay, as a broadcast, so therefore the receiver antenna, okay, they need to have a physical separation. Okay, so so as to prevent overload. Okay, so with this, okay, I hope you already get the idea, okay, when the transmitting and receiving antenna can be interchanged. Okay, so on my early part of the antenna, I actually talk about the reciprocity, okay, because of the rules. So therefore, the transmitting and receiving antenna can be interchanged while keeping the key parameters like the bandwidth, okay, like the gain and the radiation pattern, and also the impedance, they will be still the same whether is it transmitter or receiving antenna. So next, later on, I actually discuss the 6 reasons, okay, when the transmitting and receiving antenna can be interchanged. With this, I'd like to end my discussion. Okay, please help to like this video and subscribe to this channel. Once again, thank you so much for strong support. I hope to see you guys soon. Bye for now. Thank you so much.